Hello everyone, welcome to my channel GVS Chem. In this video, I am going to explain the titration of oxalic acid with potassium permanganate, which is very useful to the board practical examination, which is scheduled in the month of January and February. Please subscribe to my channel, like, share and comment my videos.
Titration is the process of adding a calculated amount of one chemical to another chemical to complete the reaction. Adding the addition of a calculated amount of one chemical into another chemical to carry out the reaction or to complete the reaction, that is a titration. Now, titrations, very different varieties are there. Acid-base titrations are there. Acid-base titrations are permanganate titrations or dichromate titrations. Right. Now let us discuss the permanganate titrations. Permanganate titrations. So permanganate titration of oxalic acid with permanganate. Titration of oxalic acid with potassium permanganate. What is oxalic acid? Oxalic acid is COOH. It is a dicarboxylic acid. 2H2O. This is referred as water of crystallization. Most of the chemicals have water of crystallization. Water of crystallization means certain number of molecules are associated with one molecule of the given substance, that is water of crystallization. Now, this oxalic acid gives C2O4 2-. This is oxalate ion. Right. So when it is dissolved in water, when oxalic acid is dissolved in water, oxalate ion is given. Now, potassium permanganate, KMnO4. Potassium permanganate is dark violet. Violet, or you can say pink, solid. It's a solid, right? If a speck of potassium permanganate is dissolved in water, you will get a violet colored solution. So gives violet colored solution. Now you have to prepare the solutions. What solutions? Oxalic acid solution and permanganate solution. Right. Now preparation of oxalic acid. How do we prepare the oxalic acid? Preparation of oxalic acid of 0.05 m solution. 0.05 molar solution. How do we prepare the 0.5 m molar solution? First of all, molar mass of oxalic acid is 126 gram molar mass, right? So if 126 grams is dissolved in water, dissolved in 1 liter, this is 1 mole. If 126 grams of oxalic acid is dissolved in 1 liter, it becomes 1 mole. If 12.6 gram is dissolved in 1 liter, this is 0.1 mole. 0.1 mole. If 1.26 gram is dissolved in 1 liter, this becomes 0.01. 0.01 mole. Now let us prepare 0.05. To prepare 0.05 molar oxalic acid solution, how much amount of solute you have to prepare? This into 5. 1.26 into 5. How much this is? 6.3 grams of oxalic acid is to be dissolved in 1 liter of solution. Right. So 6.3 gram of oxalic acid is to be dissolved in 1 liter. Now, keep the point in mind. Your question will be asked in this manner. Prepare 0.05 molar oxalic acid and using that 0.05 molar oxalic acid, determine the strength of the given KMnO4. Strength means amount of substance present in the given volume of the solution. So find the strength. To find the strength, you have to find the molarity. To find the molarity, we have to titrate. Titrate means, see, we take the calculated amount of we have to take permanganate in burette. This is the burette. On this burette, there is a graduations. Graduations means measurements. These measurements are from 0 to 50. That means the capacity of this burette is 50 ml. Right. Now, fill the burette with permanganate. How do we fill? The filling is a separate process. When you take 5 ml of permanganate, then rinse it. Rinse it means, yes, release this knob so that some of the permanganate comes out, therefore it gets washed. Then after that, hold in this manner and rotate so that all the walls of the burette are washed with the permanganate. Then once the washing is over, again release the knob, all the solution drains out. Then once this is nothing but washing of the burette. Initially you have to wash with the distilled water, then wash with the permanganate. Then fill it. Right. Now while filling the burette, take out the burette and pour it. Take care that any chemical should not fall on your hand. So it shows your accuracy. Right, your concentration will be right. Now once the burette is filled, see there the burette is fixed to the stand, burette stand.
Tripod stand.
Right. It's not tripod stand, burette stand. Right, now Mohar salt we should prepare. We prepare properly permanganate. Mohar salt we have to prepare. After preparing the Mohar salt, take out the pipette. This is pipette. The pipette is 20 ml. Pipette here is 20 ml. Then suck the water. Experiment. See here in the burette there is a marking. If you bring the liquid solution or water up to this marking, it is understood that the volume is 20 ml. So this is a 20 ml burette. There will be 10 ml burettes, 25 ml burettes also. So this is 20 ml burette. Now hold it, suck. While you are sucking, take care that here you have a bulb. What is the purpose of the bulb? If you suck the solution speedily, it may go into the mouth. So this bulb has more capacity. Because of the more capacity, what happens when you are sucking, you can see also. Therefore, you can take care. Therefore, solution doesn't go into the mouth. Now, once you suck this, you see here the marking. So slowly release this finger. See my finger. If my finger release it slowly, what happens? The liquid is coming drop by drop. So that what happens? The level comes up to this marking. So you have to suck more, take more, and release drop by drop. Therefore, what happens? The liquid comes up to the mark. Now, once you take it, you take this 20 ml of solution into the conical flask. 250 ml conical flask or 500 ml conical flask. Now see that there should be no air bubble. Here is a air bubble. There should be no air bubble. Now release it. The liquid is coming down. Now once all the liquid is drained out, here one drop is left. Don't blow the drop in that manner. Don't blow out the dot. Blow out the drop. Excluding that drop, this is a 20 ml of the solution. Excluding the drop, the volume is 20 ml. Got it? So now what happens? We take this oxalic acid, 20 ml of oxalic acid. Where is that? 20 ml of oxalic acid in a conical flask. Add 1 test tube full of dilute sulfuric acid. 1 test tube full of dilute sulfuric acid. Then heat it over the flame till it reaches 60 to 70 degrees centigrade. How do you know that it reaches 60 to 70 degrees? The hot baker just you keep it. Hot baker you keep it on your hand. If you feel it is not bearable, then it is understood that the temperature reaches to over and above 70 degrees centigrade. If it is not heated, what happens? The rate of reaction is very slow. You have to go on stirring hours together. Right? See, this I made the titration, one sample titration I made. Now what happens when you are draining out the permanganate into this? What happens? The pink violet color of the dark pink color of the permanganate becomes colorless. Now, permanganate is considered as a self-indicator. What is meant by indicator? You studied already in 11th class. Indicator is a substance which indicates the completion of the reaction. Because most of the substances or solutions are colorless solutions. If you go on adding the one solution to another solution, we do not know whether the reaction is completed or not. Therefore, to understand the completion of the reaction, one color should be there. That means that color should be different before completion of the reaction and after completion of the reaction. Now in this case, permanganate before completion of the reaction it becomes a pink. After the completion of the reaction it becomes a colorless. So you go on adding and of course go on stirring. Whatever the permanganate is being added, it loses its color continuously. Now you go on adding such until a light violet color or pink color is left in the beaker. That means as a light violet color is left in the conical flask means we can understand that the reaction is completed. Once the reaction is completed, then you see the bullet reading up to how much column comes, just you make that. So in this manner, you have to complete 4 titrations. Out of 4 titrations, the first titration you go on fast, that means you can understand approximately what value you are getting. And of course from the second titration onwards, you have to do carefully and find out exactly what will be the reading. Right. Now the weight is approximately 0.9 grams. Oxalic acid is the reading. This is oxalic acid. Oxalic acid C2H4O2 2H2O, molar mass is 126 grams. Now while seeing the reading, take out the oxalic acid. So how much weight you have to take? 6.3 grams for preparing 0.05 molar 1 liter solution. So now it is previously the weight of the paper is 0.9 grams. Now 6.3 plus 0.9, how much? 7.2. So even if 0.1 gram or 0.2 gram become excess, don't do anything. Right? Again we take the weight of empty paper and we can calculate the molarity. So you take this substance and dissolve in it. Okay, this is 1 liter. Now dissolve it and of course stir it. Now take the weight of empty paper. Okay. Now, so take the 20 ml of this one. Now, this is the marking. Slowly leave it. Now, okay. Now, allow this oxalic acid into the conical flask. So don't blow this final drop. Leave it. To this 20 ml of oxalic acid, add 1 test tube full of dilute sulfuric acid. Dilute sulfuric acid. So here it is the dilute sulfuric acid. Dilute sulfuric acid. Add 1 test tube full of dilute sulfuric acid. So this is 1 test tube full of dilute sulfuric acid. 1 test tube full of dilute sulfuric acid is around 16 to 18 ml. So add this. Why should we add dilute sulfuric acid? To prevent the hydrolysis of the substance which is to be titrated. Okay. Now what is it? Now heat this. See here, allowed. Therefore, see that there should be no air bubble. Why should we heat the substance? To enhance the rate of the reaction. Chemical kinetics you studied, no?
Yes, sir.
Temperature, 10 degrees rise in temperature increases the rate almost double. So now it reaches sufficient temperature. Now add this, add slowly. Now this is, of course, the reading is not exactly at 0. It is at 0.5 ml. 0.5 ml. So add slowly. So I am showing you the first titration. Shake it thoroughly. Color disappears. If you do not shake properly, what happens? Within 1 drop you got the color and you may feel that reaction is completed. See, because the temperature is very high now,
Yes, sir.
even if I do not shake, the color is disappearing because the rate of the reaction is almost double. That means 100%. First titration, of course, we may have to add more amount of permanganate. Sometimes the burette may be filled second time also. Now, see, pink tinges are able to observe.
Yes, sir.
The color should be still lighter. That is the end point. We call this as end point. End point means completion of the reaction. Of course, it may require. So, to confirm, just you stir it thoroughly. Now the color is not disappearing. That means the reaction is completed. Once the reaction is completed, you see the burette reading. When you are seeing the burette reading, exactly, you keep the burette in parallel to the eye. If you see like this or if you see like this, what happens? There will be parallax error and 0.2 ml may be different. Now what is this reading? The reading is 41.8. The reading is 41.8. Now let us do calculations. For this titration process, we have to do 4 titrations, that is 4 experiments. But in practice, in this experiment, I completed only 1 titration, but in practice, in a practical examination, you have to carry out 4 titrations, out of which 2 titrations must have concurrent values. That is, titer values, 2 titer values must be same. Now let us write the table first. So table experiment number, volume of oxalic acid,
volume of oxalic acid. Burette reading. Burette reading. In burette reading we have two, that is initial value and final value, and volume of potassium permanganate. Volume of potassium permanganate. So we check in this manner. Whatever the first experiment I did, I shall write here experiment number 1. Oxalic acid I took 20 ml, burette initial reading 0.5 ml and final reading 41.8. So what is this value? Volume of permanganate is 41.3 ml. Now formula used for calculations. Formula used for calculations. So formula used for titration calculations: molarity of KMnO4 into volume of KMnO4 by molarity of oxalic acid into volume of oxalic acid is equal to 2 by 5. Now molarity of permanganate is KMnO4. This we have to find. Volume of KMnO4 equal to 41.3 ml. Now, so volume of potassium permanganate is 41.3 obtained from burette reading, that is a titer value. Now, molarity of oxalic acid. How much we prepared? 0.05 m. Molarity of oxalic acid prepared is 0.05 m. Volume of oxalic acid. We took 20 ml of oxalic acid using a pipette. Now, let us substitute all these values in the formula. So here, molarity of permanganate, this we have to find KMnO4 into volume of permanganate we got 41.3 by volume of oxalic acid 20 ml into molarity is 0.05 is equal to 2 by 5. So here molarity of KMnO4 is equal to 2 by 5 into 20 into 0.05 by 41.3. So this is nothing but 2 5s 10, 0.10 into 20 by 5 into 41.3. This here 4 times. This is 0.4 by 41.3. So if we calculate this, the final value we got 0.0096. This is approximately 0.001 m. Therefore molarity of KMnO4 obtained as 0.001 m. So in this way we can complete the experiment and make the calculations, and in the similar manner we can use even Mohr salt also, Mohr salt titrations.